The hypothalamus is found in all vertebrate brains. In humans, it's about the size of a small grape and sits just below the thalamus and above the brainstem. It plays a central role in coordinating the body's autonomic response to information conveyed through limbic structures like the amygdala and higher structures like cortex. Thus, while the hypothalamus is generally described as part of the limbic system, its function only sometimes involves the limbic information. The hypothalamus is really best characterized as something of a thermostat for the body's internal milieu. Its many small nuclei take in information about the levels of different vital factors in the body, like heart rate, plasma sodium concentration, and temperature. These nuclei then compare the measured levels to an optimal set point for physiological function. If levels are too far from the set point, the hypothalamus motivates corrective behavior to restore them. The hypothalamus's central role is the maintenance of internal homeostasis, a steady state of equilibrium and physiological constancy. When homeostasis is threatened, the hypothalamus mounts a three-pronged response, engaging the autonomic nervous system, the endocrine system, and the behavioral system. It sends commands to the brainstem and the spinal cord that activate autonomic preganglionic neurons to mount a fight or flight, or rest and digest, response. It also activates the basal ganglia and the cortex and controls hormone release via a structure called the pituitary gland. The hypothalamus is what makes you feel hungry and thirsty, motivating you to seek out food when your energy levels are depleted, and water when your plasma osmolarity is unbalanced. It is centrally involved in regulating body temperature, fatigue, and the need for sleep, as well as the maintenance of circadian rhythms. Each of these regulatory roles involves the three-pronged approach to maintaining homeostasis. Consider body temperature as regulated by the hypothalamus. When your body gets too cold, the hypothalamus generates an autonomic response, causing blood vessels in the skin to constrict, which decreases the amount of heat the body loses. The hypothalamus also generates a motor response by signaling the basal ganglia and cortex, which induces shivering, to increase heat generated to warm you. It also motivates the creature, human or animal, to physically move towards a heat source. Finally, the hypothalamus generates a hormonal response to alter the internal processes that generate heat. Interestingly, the hypothalamus also generates the drive to have sex, as well as important aspects of parenting and attachment behaviors. When the hypothalamus is injured, vital factors can become critically dysregulated. For instance, head trauma that impacts the hypothalamus can produce long-term hypothermia. Patients with injuries to the hypothalamus show increased sweating and dilation of the skin's blood vessels. These responses are adaptive when you're baking in the sun on a hot summer's day, not so much when your body's temperature is far below healthy levels. Certain forms of hypothalamic tumors have been shown to cause greatly increased food consumption and the development of marked obesity. Disturbing the hypothalamus may also have a significant effect on appetite regulation. The hypothalamus is organized into many discrete nuclei, each measuring and generating a response to changes in different vital factors, and thus particular types of impairment result from the damage to particular nuclei. When treating such disorders, doctors have to worry about the specificity of the medicines they apply, as increasing or decreasing hypothalamic activity might help one dysregulated nucleus, but it will also have wide-ranging impacts on other systems. It's a pattern we'll see again and again throughout our study of neuroscience. Human intervention in complex biological circuitry must be undertaken very, very carefully, as few processes may be directly targeted without serious consequences for a plethora of other interconnected systems.